On to this next few pages, a graph now using the intercepts. So we were a little premature before when we did some of this. So we have a couple of tools in our pocket. And here we definitely want to use the X and Y intercept t-chart. So let's see if you can solve this one. So if X is a 0, you have a negative Y equals a negative 9, which makes Y then a positive 9. And if this is 0, our Y, we're going to divide both sides by 3. This gives us a negative 3. And then we take it over to our graph. Now, in this case, it doesn't quite go enough spots, so we're going to make each line 2. So this will be 2, 4, 6, 8, 9 is right about there. 2, 4, 6, 8, 9. And then we want a negative 3, 0. So this is a negative 2, negative 3 will be right about there. And we make our line. And what did we use to graph it? I'm a little bit off, but we use the X and Y intercepts. So again, we're going to use the X and Y intercepts. And see what you come up with. So if X is a 0 here, we divide both sides by 5, Y is 6. And if Y is a 0, X will be 5. So I think we might have enough room here. So 0, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6 right there. And 5, 0. 1, 2, 3, 4, 5. And our line tool, like so. Off a little bit there. All right, we'll use the same technique. X and Y intercept t-chart. And we'll give you a moment. So here, if X is 0, a positive Y will be 7. And if Y is 0, X equals a negative 7. And we'll do this one, which is similar. If X is 0, Y is 10. If Y is 0, X will be a negative 1. So again, putting them into the graph. So graphing these using our intercepts, this one will look like so, and this one will look like so. All right, on to our last one. Now in this one we're going to end up with fractions here. Little flashback. So I would suggest when that happens, you solve it by solving for Y, as we did before. Transpose that over, and that will give you a negative 2x plus 1. Divide everything by 5. So we get Y equals a negative 2/5 x plus 1/5. So our y-intercept now is a positive 1/5. And again, depending what type of graph they give you to work with, here 1/5 is just about there. And we're going to go over to the left 5. So 1, 2, 3, 4, 5, right about there. And now we're going to go up 2. So there's 1 and there's 2. So make our line, shooting that a little bit. And that's about like so. Going on to the next page, if we have a little review of what we've been mentioning in previous classes, that if the slopes equal each other or are the same, but the y-intercepts are different, then the lines are parallel. Here, if the slopes are multiplied, that is, the product of the slopes equal a -1, such as 1/3 times a -3/1, its negative reciprocal, that's a -1, the lines are perpendicular. All the others would be neither. So when you see something like this, how do you figure out whether they are parallel, perpendicular, or neither? And the key to this is solve each equation as we go down through the list for y by putting it into slope-intercept. Y equals mx plus b. This way you can compare the slopes and the y-intercepts. If the slopes are the same and the y-intercepts the same, those are the same lines. But if the slopes are the same, but the y-intercepts are different, then they are parallel. Product of the slopes equal -1, the lines are perpendicular. So this is what we need to do. Solve each equation for y. So 5y equals, bring this over, -2x plus 3. Divide everything by 5. So we get y equals a -2/5 x plus 3/5. And this one, 5y equals, bring your 2 over, -2x plus 8. Now divide everything by 5. Y equals a -2/5 x plus 8/5. So now we compare our slopes. Here, this one is a -2/5. Here, this is a -2/5. Here, the y-intercept is 3/5. Here, it's 8/5. So the lines are parallel. And this is the proof of it. This is what I want to see on these pages, that you have the technique needed to get to a solution. All right, let's do number 2. So we've transposed the positive 4x to this side, divided everything by 3. I now have it in slope-intercept. Now I want my y to be positive, so I transpose this to the other side where it's positive, transpose this to the other side where it's negative, divided everything by 4 and just rewrote it this way. So now what we can do is look at this slope and look at this slope. Now this is the negative reciprocal of this. And if you multiply your slopes together, it produces a product of -1. So this set of equations are perpendicular to each other. This one was parallel. So in example 3 now, again, solve for y. That is your proof. Let's do it this way. 2y equals a -3x plus 10. Transposing the 3x to the other side. Now divide everything by 2. A -3/2 x. 10 divided by 2 is 5. Now again, our y is negative, so I'll bring it over to this side. 3y equals 2x minus 6. So I'm going to divide everything by 3 now. So I get y equals 2/3 x minus 2. I'm just writing it the other way. So this is a y, and to divide each of these by 2. Now I'm going to compare my slopes. Here the slope is a -3/2. Here it's a positive 2/3. This is the negative reciprocal of this. The product of the slopes is 1, so the lines are perpendicular. That's the symbol for perpendicular. All right, give this one a shot. So 2y equals a -3x plus 10. Divide everything by 2, so y equals a -3/2 x plus 5. Well, I guess that's the same, isn't it? Yep. And this one, the only difference is that this is a plus here. So we'll leave that on this side. So this will be 3y equals, transpose this to a -2x plus 6. Just bringing that 2x to the other side. Divide everything by 3 now. Y equals a -2/3 x plus 2. Again, we're comparing our slopes. Are the slopes the same? Well, here it's a -3/2, and this is a -2/3. Now, if we multiply these together, it gives us a +1, but not a -1. And the slopes are not the same. So for number 4, this is neither. And you have the proof here. The slopes are not the same. They're reciprocals, but not a negative reciprocal. Ah, okay. So the product of a +1, that was a little tricky. And there's the last one. We'll give you some time, but we're going to solve for y. So 2y equals a -3x plus 5. Divide everything by 2. Y equals a -3/2 x plus 5/2. Again, solve this one for y. 3y equals, transpose this, -2x plus 4. Divide everything by 3. Y equals a -2/3 x. And this is going to be plus 4/3. Compare your slopes. This is a -3/2. This is a negative 2/3. Again, the slopes are not the same. They are reciprocals of each other, but that gives you a positive one. So this is another neither. For these, they want us to write an equation in slope-intercept form here, in which they give us the slope and 1 point. Now, for these, what we have to do is use what we're calling equation 4 for reference. This is the point-slope form. Y minus y sub 1 equals m, the slope, times x minus x sub 1, where we have 1 point and the slope. 1 point and the slope. So let's substitute this into this equation, and we'll give you a moment. Should look like that. Clear parentheses, y minus 2 equals a negative 5x, distribute, plus 5. Take this, bring it to the other side where it becomes a plus 2. So our equation now is y equals a negative 5x plus 7. All right, let's do the same thing with number 2. So when we substitute the single point and the slope, we end up with something like this. Now notice, since there's a negative in the formula and our y sub 1 here is a negative, we have two negatives, so this is just going to become a positive. And in the future you can just immediately write the positive. But now we want to get rid of this 7 as a fraction. So we're going to use the technique of multiplying each term by 7. Here all of this is just one term, and here the 7's cancel out. So we now have 7y plus 35. Now notice, since the 7's gone, we just have to distribute the 6x minus 24. And again, we want it in slope-intercept form, so we're going to transpose this to the other side, where it becomes a negative 35. And we now have 7y equals 6x. And we add this up and get a negative 59. And now we divide everything by 7. So we end up with y equals 6/7 x minus 59/7. Now notice, doing this little technique here made it much easier to solve. So I strongly advise you adding that to your repertoire of moves. Now as we look at number 3, it's a line that goes through this point. And remember, another way of writing that is A, comma B is an ordered pair, and it has an undefined slope. So if you recall on that worksheet, we said formula 6 was the equation for an undefined slope. What was that equation? And it was x equals a. So for this, we're going to get x equals what is in our a position? The negative 5. And that's the answer to this one. So as we look at example 4, it says the line passes through the origin and has a slope of -3. Well, here's the slope-intercept form, but now they're saying that b is 0. So in a sense, there is no b. And here's most of our equation. So all we have to do is put our slope there. Y equals -3x. And that's as easy as this one is, if you're following along with what's going on. Now here's a line that's going through this point, and it's vertical. Well, what was the equation we said for a vertical line? That was still formula 6. X equals a. That would be undefined slope. So, what's in our a position? 3. X equals 3. Now, they don't have this one. I'm making up an extra problem here. Example 6. Write this in your booklet. Here the slope is 0, and it goes through this point. What would be the formula in slope-intercept? Well, here, when slope is 0, we use formula 5, which is y equals b. And what is in the b position here? The 4. So y equals 4. I'm surprised they didn't ask that. They gave 2 using formula 6.